Hello friends, welcome back my YouTube channel MS Maths. In this video, I will discuss or explain the series of real number, and this is part 1. I will start from the introduction of series and I'll go to the definition, example, sequence of partial sum, and we'll see some properties and some examples of series and sum of series. So basically, what is the meaning of a series that we are going to discuss here? So my name is Manoj Solanki. I will start the topic. So first thing is that series is something like that. If you have any of the sequence and if you add each and every term of sequence, then it will be a series. So watch my previous video in which you will get the concept of series. I have completed around 5 to 4 like six part in that topic of the sequence, so you can go through with the sequence. So now in this video I will discuss the definition. So from here, the definition is what? Let an be a sequence of real number, then the expression, this is what the summation of an, that is a1 plus a2 plus a3 up to an, or like up to an and then next to an, that is called the sequence or real series, or we can say the infinite series also. Okay, we can have some example of series. Let's say if it is an is a sequence, let's say it is my n sequence. So I will just make it like this series. So it means summation of n. So n will okay, in the sequence is a mapping in which it will start from natural number to real number. It means it will start from natural numbers. So it is nothing but 1 plus 2 plus 3 up to n. Okay, this is what the thing here. Then let's say if I will write summation n square, and it is nothing but 1 square plus 2 square plus 3 square and up to n square, that or up to infinity that it will go. Let's say if I will take any of the sequence that is 1 sine 1 by n, then it is nothing but sine 1 plus sine 1 by 2 plus sine 1 by 3 here. So it is something like that. We can assume the example or the definition of the series. Okay, now what is the property of the series? Okay, now if I want to identify my series or is convergent or not, because if there is any sequence, then we will just find out the limit, but here we will not find out the limit. Actually we'll find out the sum. If sum is convergent, then we'll say the series is actually the convergent, or if it is not convergent, that we will see here. So yeah, let's say it is what the sequence of partial sum. Sequence of partial sum is something that using we can identify that the series is convergent or not. Now first of all, just try to understand what is the sequence of partial sum. So if you have, let's say if it is my sequence, or sorry, if it is my series, let's say it is a1 plus a2 plus a3, then what is, I will create a sequence by series. What is that sequence? That is what my s1 is nothing but first term. Okay, s2 is nothing but my first sum of first two term. S3 is nothing but sum of first three terms. So Sn is nothing but sum of first n terms. Okay, 2, A3 and up to An. Now I have these terms. So I will make the sequence Sn. I will make the sum of partial sum. If this sequence will converge, then I will say my series will converge. This is what one of the important observation from here. Okay, then sequence of Sn is called the partial sum, or let's say SOPS. What? SOPS. Okay, now nature of this series, it's same as its SOPS. Whatever, if it is convergent, it will converge. If it is divergent, it will diverge. But yeah, series can't be oscillate anywhere. So if an is a convergent, okay, an is convergent, converging to L, it means that SOPS, this is what the sequence will converge to N. If it is diverging, then it will diverge, but it will not oscillating. It means series is sufficient to all whether series is convergent or not, but we can find the sum of series in particular cases. Okay, so this is what one of the thing here that we can see here. Now we will just identify, these are all about series and its definition. Now we'll go to the questions and we'll hit the question. So we'll have some like we can say like some predefined series is here, or we can express function in the form of series here. Okay, this is what sine of x. I can express this using Taylor series expansion, that is nothing but x minus x cube by 3 factorial plus x power 5 by 5 factorial. Okay, cos x is nothing but 1 minus x square and even terms. E power x is 1 plus x square or something like that, x power n upon n factorial, that we can see here. log of 1 plus x, that is what the odd terms. Okay, log of 1 plus x, yeah, it is even, no, sorry, not even terms, it is looking like e power x, but here it is not factorial. Okay, x minus x square by 2 x cube by 3, and 1 minus x is something all positive term, but okay, yeah, all negative term, or you can take the whole negative to the all of the where like terms here, x plus x square by 2 plus x cube by 3. This is the trick that you can understand the thing. Then log of 1 plus x minus, this is what one of the observation from this sequence and this sequence. If we'll add both like this, or if you'll subtract this and divide by 2, then you will get this sequence looking like sine sequence, but it is not sine sequence. Just it is what it is, a sequence like looking like sine sequence, but it is all positive terms and no factorial terms are there. Okay, so these are some basic series, and we are going to use these series to solve some questions. Next one is the telescoping series, which is something like this, in which you have next term is this. Okay, so bn in the form of something an minus an plus 1 minus an. Okay, one thing is that I just want to tell you, that is what the observation. Okay, one of the form of the matrix, if your sequence is something like this, n into n plus 1, then the sum of this sequence, okay, from 1 to infinity, then sum of the sequence is going to be 1 only. Let's say if your series is not sum of sequence, sum of series, okay, n tend to infinity 1 upon n, n plus 1, n plus 2. Now it is nothing but 1 by 4. Now how can I identify this? So there is one result, or that you can easily, that you can directly keep in your mind, that is n is equals to 1 to infinity, whatever it is. Let's say it is n, n plus 1, n plus 2, up to n plus m. Then it is nothing but m factorial. Okay, if it is n plus 10, up to n plus 10, then it will be 1 by 10 factorial. Okay, this is one of the results that you can keep in your mind. Now I will tell you how can we solve some sort of example using the previous few examples of the sequences, and which is arise in the questions generally, which is in the exams. That I will solve question one by one here. So find the sum of series. Okay, the sum of series that is given here. Let's say summation n is equals to 1 to infinity n square minus n plus 1. So from here, this question, you will understand how to use these like formulas of the sequences. Okay, so this is what your sequence divided by n factorial. So first of all, just try to make it, or just identify. If it is factorial, then just see which form may be this. Okay, it either it may be like sin x, cos x, or e power x, because log term can't be there because there is no factorial in the denominator. Just identify this. Okay, so it means I can just make like any of the e. How can I make? Just simple. Just write like this: n square minus n divided by n factorial. N is equals to 1 to infinity, and from here I can just simplify, write n is equals to 1 to infinity. It is nothing but 1 over n factorial. Okay, now what is the meaning of 1 over n factorial? Just e to the power x means 1 plus x square over 2 factorial, x cube over 3 factorial. If I will take x is equals to 1, then e power 1 is nothing but 1 plus 1 plus 1 over 2 factorial, 1 over 3 factorial. It means, what is this? If I will express this, n is equals to 1 to infinity n square minus n, okay, upon n factorial, and it is what? If I will express, if I will put n, then it is nothing but 1 plus 1 upon 2 factorial, 1 upon 3 factorial. It means it is starting from here. Then what about this? I can easily write e power 1 minus 1 is equals to 1 plus 1 upon 2 factorial, 1 upon 3 factorial, whatever it is. So I can use this here. So it is nothing but summation n is equals to 1 to infinity n square minus n upon n factorial. That is what? E to the power 1 minus 1. So at the place of this, I can replace this formula. This is how you can use the formulas of the sequence series here. Now, my task is to create or just solve this part. Now, if I will take n is equals to 1 to infinity, I can take common n minus 1, and I can express this n factorial as what? N factorial is n minus 1, n minus 2 factorial. Then it will be it will easily then can be cancelled. Okay, now from here I can just write like this. Okay, it is e to the power 1 minus 1. So if now n is starting, n is going to be start from here, what n is equals to 2. So here n is equals to 2 to infinity, then it is nothing but 1 upon n minus 2 factorial plus e to the power 1 minus 1. Just express it. You will get what? 0 factor. Okay, 1 upon 0 factorial. So it is what? 1 upon 0 factorial. Then after 1 upon 1 factorial. Then after 1 upon 2 factorial. So it is nothing but your e. So this is going to be e power 1. So it is e plus e minus 1. It means the solution is 2e minus 1. This is what the solution or the sum of the provided series. Okay, how you can get the result. So this is the result of the provided series. Clear? Next. Yes, this is what the result. Next, we'll take one more example so that we can get our concept clear. Next example. Find the sum of series n is equals to 1 to infinite, that is n square upon n factorial. Now, what is the meaning of this? Can I write like this here? So if I will solve this summation n is equals to 1 to infinity, then it is n square. Okay, if I'll write like this n square n factorial, or let's say n into n minus 1, it will not work a lot. Okay, at all. Then I will use this. I will just add 1 and I will subtract 1, then it is minus 1. Now what will happen here? So yeah, first thing is that I can do, that is what? N minus 1 factorial into n. Now it is again going to be simple, infinity, and this is n upon n minus 1. Now if I really want to remove this numerator n from here, then I will just I will subtract 1 from here and I will add. So it is nothing but n minus 1, or let's say n minus 2 factorial. Then I can easily write from here, that is what? N minus 1 divided by n minus 1 n minus 2 factorial. Okay, plus summation n is equals to 1 to infinity, that is what? 1 upon n minus 1 factorial. That is the combination of this. I can write in simple. From here it is n is equals to 1 to infinity, but yeah, from here it is n is equals to 1 to infinity. Now from here I can just write n is equals to, because it can't be negative, 1 minus 2, it can't be negative, so it will be 2. So 2 to infinity, 1 upon n minus 2 factorial. And this is nothing but n is equals to 1 to infinity, 1 upon n minus 1 factorial. Now it is nothing but what? It is your e power 1. It is again e power 1. So it is 2 into e. This is how we can use the sum of series. I will take one more example so that we can get concept clear. Okay. Yes. This is what your result here. So find the sum of the series. Let's say if I have the series in the form of 1 plus 3 upon 2 factorial. Again, it is factorial. It means it will go to exponential. Okay, I will think about the exponential only. Then it is what? 2 or 3 factorial. So it means it is something like this. So I can easily, what is the nth term? It will be 1 plus 3 square up to this. It is 3 power n, then nothing but 3 factorial. Okay, not 3 factorial. It is 2, 3, 4. It means n factorial. Now it is what? GP. So just think over the GP. What is the GP? That is what? 1, a power 1, a power 2, up to a power n. Then I will find the common difference. That is nothing but a upon 1. It is nothing but a. It means the next term divided by previous term. Okay, if it is the form of GP. Then here, if it is greater than of 1, then I will just write a r power n minus 1 divided by r minus 1. This is what the SN, sum of this kind of GP. So for this numerator, I can use this result. So what is the result? From 1 to infinity, that is what the sum n is equals to 1 to infinity. This is nothing but 1 plus, okay, I can use, okay, what is r here? R is nothing but 3. Okay, 3 by 1 is 3. So it will be 3. Okay, sorry. Yeah, a is 1, r is 3. So 3 power n minus 1 divided by r minus 1. R is what? 3. So 3 minus 1, that is 2 here, and into n factorial. Then I can easily write 1 by 2, n is equals to 1 to infinity. So 3 power n minus 1 divided by n factorial. Now my ultimate aim is what? My aim is to make it, because of that it is n factorial, I will think about only the exponential. So this is 1 by 2 here, and this is n is equals to 1 to n. I will take it separately, or I will just write it like this: 3 power n divided by n factorial minus summation n is equals to 1 to infinity 1 over n factorial. So I will just express this, then it is nothing but 1 by 2. So it is what? 3 power n. So if I will write like this is nothing but 3 divided by 0 factorial. Okay, not, yeah, 3 divided by 1 factorial. Okay, by 1 factorial. 3 power 2 divided by 2 factorial. Okay, n starting from 1. 3 power 3, it is 3 factorial. Means like, just try to see. Okay, this is one of the part. Okay, the next part is what? 1 upon 1 factorial, 1 upon 2 factorial, okay, up to 1 upon n factorial. Now just see about both the things. It is nothing but x plus x square by 2. Then what about 1 here? It means I will just write like this: e minus 1. What is x? That is 3. So it is 3. So 3 square minus 1. So from here it is nothing but e minus 1. So I will just write 1 by 2. It is e power 3 minus 1 and minus e minus 1. So this is what the thing here, that is 1 by 2 e to the power 3, okay, minus 1 by 2 minus e by 2 and plus 1 by 2. So this will get cancelled. So e power 3 minus e by 2 will be the answer of this sequence. So this is the result. How can we get this? So just think over about the sequence, and it should be very clear that how will you use this. Now let's say if I have one example like this. Okay, let's say 1 plus 1 by 3 into 1 by 4 plus 1 by 5 into 1 by 2 power 5, 1 by 7 plus or let's say into 1 upon 2 power uh, 2 power, wait, there is a problem. 1 by 5 and 2 power 7. Yes, let's say it is 2 power 7. It is 2 power 3 here. So from here I can easily see. Wait. It is 4 power 2. Okay, the question is something this. Wait, question is wrong here. Wait. Yeah, 1 plus 1 by 3 into 1 by 4 plus 1 by 5 into 1 by 4 square plus 1 by 7 into 1 by 4 cube. This is what the question. Can I write this question in the form of this? I will just divide and multiply with 2. This is 1 by 2. This is what? 1 by 3 into 1 by 2 power 2. This is what? 1 by 5. I have taken 2. Okay, so this is nothing but 1 by 2 power. From here, it is nothing but 2 power 3. It will be 2 power 3 because I am just multiplying, dividing with this, and this is 2 power 5. So I'm getting it is as, if I will write like this, 2, and this is what? 1 by 2 upon 1. Okay, plus 1 by 2 power 3 upon 3, 1 by 2 power 5 upon 5. Just see this. It is what? Now, if you are going to take 1 by 2 or 1 by 3, 1 by 5, just see this 3, 5, and it is nothing but log 1 plus x by 2. So it is not nothing but log. It is what? Log 1 plus x minus log 1 minus x divided by 2. It is nothing but what? X plus x cube by 3 x power 5 by 5. Okay, so from here it is nothing but 2 into, this is what is x here. So from here x is 1 by 2. So it is nothing but log 1 plus 1 by 2 minus log 1 minus 1 by 2 divide by 2. So from here 2 and 2 will get cancelled. So this is nothing but log 3 by 4, sorry, 3 by 2 minus from here log 1 by 2. So I can just write log of 3 minus log of 2, then log of 1 minus, okay, from here it is what, log of 1 minus or plus log of 2. So from here it will get cancelled and it is nothing but log of 3 because log 1 is going to 0 from here. So this is what the thing that we can solve, and we can easily see how can we use the certain properties or certain sum of series here. Now I will solve one more questions. Question number 4, or I think, yeah, what are the question number? Okay, just see. I will take 1 upon 2 into 3 plus 1 upon 4 into 5, 1 upon 6 into 7, whatever it is. Okay, now how can I solve this question? Just take it as simple. So can I write like this, 1 by 2 minus 1 by 3? Whatever the result from here, I can get from here. It is nothing but 1 by 4 minus 1 by 5. Okay, then it is 1 by 6 minus 1 by 7. It means I can just make like this, 1 minus 1 by 2 plus 1 by 3. If I will just write like this, okay, then minus 1 by 4 plus 1 by 5. If I'll take plus 1, so it means just add minus 1 and plus 1, then I can easily get, this is nothing but my minus of log 2 plus 1, and okay, this is minus of log 2 and plus 1, and this is nothing but 1 minus log 2, that we can easily get it from here. Okay, this is what one of the question. And if I will take like this, if it is what, n is equals to 1 to infinity minus 1 power n plus 1, and it is 1 by n minus 1 upon n, can I find the result? That is what the simple, I will take minus common, or n is equals to 1, and this is what, infinity. So minus 1 power n plus 1 divided by n. Okay, minus, okay, not equals to, okay, no taking of minus, yeah, yes, and this is what the summation n is equals to 1 to infinity minus 1 power n, and it is n plus 1. Now it is what, it is nothing but, it is, if there is no factorial, then don't think about the any of the exponential, it will be only logarithm. So it is nothing but log of 2. Okay, why log of 2? So the summation minus 1 power n plus 1 upon n is nothing but log of 2. Your here user x is 1 only, and this is your what, this is your going to be minus log of 2 minus 1, because it will start from 1. Okay, so from here it is nothing but log of 2 plus log of 2 minus 1, then that is nothing but 2 log of 2 minus 1. It means log of 4 plus 1. That is what your result here. Okay, so these are like these kind of result that you are going to you can solve. Now some sort of questions related to like this, there may be asking something like that. Okay, so using the fact that the summation of, using the fact that what we can solve here using the fact that the summation 1 over n square is pi square by 6. Okay, let's say from n is equals to 1 to infinity, if its value is pi square by 6, then what is the value? N is equals to 1 to infinity 1 upon 2n plus 3 whole square is equals to what? So what is the value? So it means you have to convert or you have to convert this form to this and use this result, and then you can easily solve. So first of all, just proceed with this. So this is nothing, if I will put 1 here, then it is what? If I will put 1 here, then it is wait, yes. So I have 2n plus 3 whole square, and I will proceed with n is equals to 1. If n is equals to 1 here, then it is what? 5 square. If n is equals to 2, then I can proceed forward. So let's say if I will start with 1 square, or let's say just use this only, whatever, you can proceed with this or with this. So it is very easy to handle this sequence. So just see, it is what, 1 upon n square, 1 upon 2 square, 1 upon 3 square, up to this, it is nothing but my pi square by 6. Okay, now I will take, this is what, this is something looking like what, odd numbers. I want to take only the odd numbers. Okay, this is what, 1 plus 1 by 3 square, 1 by 5 square, but not 1 here. Okay, on starting from 5, that will take care, and take all the even numbers like this, 1 by 2 square plus 1 by 4 square plus 1 by 6 square here, that is equals to pi square by 6. Okay, it's very easy. Just see, it is nothing but 1 plus whatever the value we want to calculate, whatever the value we want to calculate from here, that is from here, that is from basically, that is, if I'll take, let's say n is equals to 0, from here if I'll take n is equals to 0, I think from here we should take n is equals to 0, so that, yes, so if n is equals to 0, then it will start from here to here. It means this is my x, I want to find the value of this x, so I have to proceed with all these things. So this is what, let's say this is my x. Now my task is to solve only this. So how can I proceed? If I will take 1 by 2 common, then what is this? Or 1 by 4 common, then what is this? 1 plus 1 upon 2 square plus 1 upon 3 square, the same thing, whatever the given, that is pi square by 6. I can use here, what is the result? That is pi square. So it is nothing but 1 plus x plus 1 by 4. It is nothing but pi square by 6 is equals to pi square by 6. Now can I really find the value? That is 1 plus x, that I can easily find pi square by 6 minus pi square by 24. Then from here, if I'm going to solve this, or let's say x is equals to pi square by 6 minus pi square by 24 minus 1, that I can easily solve, that is nothing but pi square by 8 minus 1. So this is what, using this fact, you can solve this question. Okay, so using the value or using the result, you can solve. Now we can take one more example like this. So if you have, using the fact that summation minus 1 power n plus 1 divided by n, that is, we know this is nothing but log of 2, then it is saying to find the value. Okay, summation n is equals to 1 to infinite minus 1 power n into n plus 1 equals to, what is the value of this? Just simply started from here only. So what is the value of this? Just take it like this. Take the, first of all, in this you should proceed with this. So this is from n is equals to 1 to infinity. So minus, if I'll take the partial fraction, then it will look like this. Okay, this is something from partial fraction, minus 1 power n, and this is n plus 1. So from here it is minus 1 plus 1 by 2 minus 1 by 3 alternating. So from here, if I'll take minus common, then it is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. That is what the provided thing here. So it is, okay, I will take plus 1 here. Okay, plus the separate. This is nothing but what? Provided, that is what, log 2. This is also what? Log of 2 plus 1. This is nothing but what? Let's say 1 minus log of 4. Okay, or let's say 1 minus log of 2 here. Yes, 2. Yeah, this is, or let's say 1 minus 2 log of 2. That is nothing but log of 1 minus log of 4. This is what the result, or using these sequences or using these series, these general series, we can solve any of the questions. Okay, this is very much important here. So thanks for watching my video. Keep watching MS Maths. We'll meet in the next video. So thank you. Bye bye.